Mitchell.
All right.
Or Miss Reed.
So we have spent a lot of time exploring circuits and learning about them. So now it is time for you guys to build your own circuit. So if we were in the actual classroom, I would have you guys doing something similar to what Miss Ayana did. But since we are online, I have the next best thing for you guys, which is an online circuit simulator. So for this activity, you're going to be going to your normal breakout groups to complete this activity, and you will have 10 minutes to build a circuit. So you are going to be building a closed circuit, just like we have been discussing throughout this lesson. So you will need to include the 3 main parts. Can someone come on the mic and tell me those 3 main parts that you need to include? You can just unmute yourselves.
A power source.
Yes.
A load and an insulator.
Close. So we have a power source, we have a load. What's the 3rd main part? You can use the picture on the screen to help.
Conductor.
Yes, the conductor. So you need to include the power source, the load, and the conductor. So I'm gonna go ahead and share my screen, and I'm gonna show you guys the game. Just give me one moment. Okay. Can you guys see my screen? Yes, no?
Yes, I can.
Okay, so after I show you guys the game, I will send the link in the chat. But for now, please pay close attention as I show you the game. So you'll click play game, and then you'll wait for it to load and click intro on the left side here. And as you can see on the left side, you have all your materials that you'll need. And up at the top, you have your conductor, your power source, and your load. So make sure that you include these 3 parts in your circuit. And to use this game, all you do is click on it and you drag it over like this. So you can see that I'm doing. And if you want to delete something, all you do is you click on the object and a little trash can will appear down here, and you just click on that. And I would do that, but on my screen, it's kind of hidden. So, but you can see it down there. And so along with the 3 main parts, there's also some other objects here. You can see there's a resistor. We haven't really talked about it, but a resistor is a device used in circuits to slow down the electric current. So if you click on it, and you can change the resistance in the circuit, you can increase it and you can also decrease it. And along with that, we have a switch, and all of you should be familiar with a switch by now. We know that if you close it, it closes the circuit, and if you open it, it'll open the circuit. So if you scroll down, there are some more materials. We have a fuse, and a fuse is used to, it's a safety device used in the circuit, and it will stop the circuit if the current's moving too fast. So you can use that if you want to. And then we also have some more insulators and conductors to choose from. We have a dollar bill, a paper clip, a coin. We also have an eraser, a pencil, a hand, and a dog. So feel free to explore and to use these materials, but just make sure that you include the conductor, the power source, and the load. So I'm gonna go ahead and send the link in the chat. Just give me one moment. All right. So go ahead and click on the link, and you can go to your breakout groups. I'm gonna start my timer. Please come back at 6:18, and we will be circulating throughout the groups to check on you and see if you have any questions. And when you come back, please choose one person from your group to be the reporter to share your experiences with building the circuits, and we'll have a little discussion. So go ahead and go to your groups. I'll start the timer.
Emily.
Hey guys.
I'm confused, Rachel, actually. What are we supposed to be doing? I'm sorry.
Do you have the website pulled up?
Yeah.
Okay, so you're just making a closed circuit, basically what we've been doing throughout the whole lesson. So all you have to do is like drag the wire over. Can you share your screen actually so I can?
Mine does not work.
Oh, it doesn't work?
I don't know why it does not work.
Okay, so you just like.
I have hold on. I have it open actually. I just didn't know what we were supposed to be doing because I seen the link to the PowerPoint, that's why.
Yeah, you just make a closed circuit. You just need to include the battery and the wires and the light bulb. But you can add whatever you want.
Okay.
There's a lot of things to choose from.
Thank you.
I don't remember which one she said.
Oh, she's
Hey guys.
Yeah.
Y'all having fun building your circuit?
Yes.
Have any of y'all figured it out yet?
We just opened it.
Oh, okay.
Yes.
Hello. Oh my goodness, we got a lot going on here.
How do you cut this?
Wow, you are really experimenting over here, Brooke.
I am a dude.
I see you got your light bulb to work. That's really good.
Y'all, this isn't gonna work if I put an eraser in there. I have no clue.
Does the hand work? Oh, looks
No.
like it stopped. It's probably an insulator then if it doesn't work. Ooh,
What
a
about the
dog?
dog?
I thought the dog was so funny. Like, why? Who would put a dog in a circuit? I don't know.
Dog. Let's try the pencil.
Well, the pencil possibly could work. Oh, look at that! I wonder if the pencil is probably lead, and we know lead's a metal, right? So it's probably why it works. That's really interesting.
Let's see how many voltage this battery gets with it.
Oh,
Oh my
wow.
god.
Yeah, I think that battery has a lot of voltage.
It's just battery. What about the fuse? Oh, what? Okay, so it's going through the same voltage. It's not doing anything
All right, I'm
more.
gonna go check on some other groups. Y'all are doing a great job. Hey guys, are y'all starting to figure it out now?
Oh my god.
Yes, I got mine. Ooh.
Oh, I got it.
Can someone share their screen?
Mine
Whoever
doesn't
can.
work. I tried. I don't know why my screen doesn't share.
I can try to share mine.
Okay, cool. Did all of you get your light bulbs to turn on?
Can you all see that?
I got.
I do.
Ooh.
Oh, I like it. Have you tried using anything else?
So easy.
No, I'm not on right now.
I'm not sure mom says.
Does anyone else want to share their screen in here?
It's pretty much the same thing.
All right, well, y'all did a great job. I'm glad that all of you guys figured it out. It's really impressive.
That's funny. I like how it shows the flow.
Oh, wow. You guys have a lot going on here.
Yeah.
So you use the coin, have
Yep.
some resistors and a fuse. Nice.
Yeah. And a paperclip.
Oh, yeah, I see that now. Did y'all try using the dog? Or the dog?
Yeah, we did. It didn't work.
Didn't work. Why do you think it didn't work?
Because there was nothing like, he wasn't a conductor. He was more of like a,
There's a special word for that.
I guess an insulator maybe?
Yeah, they're
don't know.
insulators. Yeah,
So we're
insulators do
insulators,
not
then.
conduct electricity, and we know that a dog is not capable of doing that. Yeah.
Except for maybe Bolt.
Oh, Bolt, yeah.
Oh, Bolt.
He's a special dog.
Good correlation.
Does anyone else want to share their screen in here?
Oh, we were just all kind of
Oh, y'all were working on the same one?
Yeah, just
Okay.
telling me what. So.
That's cool. Well, we have about 40 seconds left, so y'all can wrap it up and choose someone to speak out. I'm just going to call in a few groups or have them volunteer, so I will see you guys in a little bit.
Okay. Thank you.
All right, perfect.
All right, so I loved all the circuits that you were building. They were really great. It seems like most of you ended up figuring out how to get the light bulb to work, and that's really impressive. A lot of you were exploring with the different materials, and I'd love to hear from all of you guys. So if I could get one person from group 1 to share, that would be awesome.
Hi, it's Annalisa from Group 1. So we used we tried a lot of different things. I guess it was kind of cool because the paperclip and the coin worked, and that was cool.
Mm-hmm.
And then we used a resistor, and we saw that the light got dimmer, and so we put another resistor, and we saw the light got even dimmer. So that was cool.
Nice. Yeah, I like that. What do you think the resistor did to the current?
I think it just kind of I maybe like slowed it down or
Mhm.
just like kind of took it back a little.
Yeah, that's great. Thank you for sharing. Can I get someone from group 2 to share, please?
Hi, it's Brooke.
Hi, Brooke.
So actually we tried all of what's it called? Like the dog, the hand, those didn't work. The eraser didn't work. And then we tried the high voltage battery and it set it on fire.
Yeah, I was in your group when I saw that. Why do you think that happened?
It just might have been like too powerful, probably. Too
Yeah.
much electricity, I don't know.
Did you notice anything about the current when you put the high voltage battery in?
Oh, we went until like 9. Or, yeah,
It was
like
moving
9,
really
I think.
fast, right?
So it was like 9.
Hey, awesome. Thank you for sharing. Can I get someone from group 3 to share?
Hello, this is Leanna. We also like went through the lineup and like tried out everything. We tried out the pencil and noticed it like decreased and like the speed got a lot slower, but like there still was some electricity there. So I thought that was really interesting. We had like multiple wires going and used the high voltage battery at one point when we had 2 light bulbs, and it like super lit up one of them but didn't light up the other one as much. So I thought that was really interesting to see like the transfer of power based on like where we put the battery.
Yeah, that's really interesting. Why do you think the pencil worked?
I think because lead is a metal, and so it is like a conductor. It's just not like 100%, I guess. I'm not 100% sure on the correct terminology there.
Yeah, it's a conductor, but it might not be the best conductor to use, right?
Yeah.
Yeah. Well, thank you for sharing. Can I get someone from group 4 to share?
It's Miss Amber, because she's the one who can share her screen. I can't, unfortunately. So if she can't do it, I can explain what we did, even though I won't have the thing on the screen, but I can explain what we did if she's not able to.
Yeah, you can just explain. That's fine.
Amber, is that cool, or would you like to take over? Oh, she might be trying to come back in too as well. What we did was we placed our battery vertical. So we know that from our battery, that's our power source. Can y'all hear me?
Yeah, we can hear
Or
you.
is it a little sketchy? Okay, cool. Our battery, our power source, and then we know that our light bulb we put on top of the positive side of our battery. That's vertical, and that was our load. And with the conductor, it's those. It's like I want to we didn't use any of the other materials. I couldn't unfortunately do it. I was just we were all talking about it, so I wasn't able to do it on my screen. But I was able to see her do it, and I noticed that there were things that were moving between the stuff. So can I? I did have a question, but I did want to finish up really quick. But I know that the stuff that was moving in between, like when we did it with our foil, like our conductor. I just wanted to know what would be those things that are moving? Is that the not currents? Like what is that moving? Is that energy? Is that the what exactly is what was that moving?
Are you talking about the little circles that were moving in the wires?
Yes.
Those are the electrons. So that is the electrical current moving along.
Okay.
Great. Well, thank you for sharing, Mia. Can I get someone from group 5 to share? I think 5 is next.
I can share. Get my screen.
Okay, perfect.
Okay, so. Oh, sorry, it's disconnected. Hold on. Here's what we did.
Oh, wow.
So we got 2 light bulbs. We tried the dog. Sadly, it didn't work. But I added a coin, and then I have 2 light bulbs. And what the professor was asking is like, how come he was asking how come this light bulb has to be sideways like that? And the reason I think so is because both ends of the light bulb have to have touched the wire before. If it's like, say the light bulb's removed, the second one is removed, the side of the light bulb and the base of the light bulb have to be touched by both wires. And so the second light bulb basically just acts, I guess, as another conductor. And then it also, you know, has like does the power as well. I mean, not provides it, but like it exemplifies the power. And so it just had, sorry, I know it's really hard, but so the second light bulb also, the wires touching the base of the first light bulb, and then the second light bulb touching the side of it, and then the side of the second light bulb was being touched by the other wire, and that's what's lighting them both up. So basically, if one of the sides of the light bulbs is not being touched by either the wire or the other light bulb, only one of the light bulb works.
Right. Yeah, and we kind of saw that with Miss Sayana's experiment when y'all were trying to figure that out. It only would light if we had both sides, you know, the bottom and the side of the light bulb. Both have to be all connected for it to work. Yeah, I really like how you made that observation. Thank you for sharing. All right, can I get someone from group 7 to share, please?
Yes. So what we did was made a normal battery blow up. So we used a resistor, and with the resistor we connected both wires into the bottom of the light bulb. And it was an open circuit, but when we closed it, it blew up the battery. But we saw how the electrons were like running through quickly around, which was interesting. But I wasn't sure why it blew up.
Yeah.
I'm sure the resistor had something to do with it though.
Did you try increasing the resistance?
No.
Oh, see, yeah, if you click on the resistor, then the little bar comes up on the bottom and you can move it up, and that will help slow down the electric current, which would prevent everything from exploding. So you can try that next time. Yeah, but thank you for sharing. All right, and then can I get someone from group 8 to share? I think that's our last group.
So what we did is we did a bulb, 2 wires, the battery, the resistor, and we closed it, and it worked. It lighted up. We also tried with just 2 regular wires, a bulb and a battery, and it worked. And then we tried the coin, 2 wires, and the bulb and the battery, but we increased the voltage on the battery, and it like lighted up a lot. So that's all we did.
All right, thank you. Yeah, if you increase the voltage too much, it might catch on fire. So that's why we have resistors, and that's why we have fuses. It's to kind of prevent that from happening, you know, to keep it safe. So great job, guys. You all did a really good job building your circuits. So now we're gonna move on to our next activity. We have a Kahoot quiz for you.
Did the graduates speak yet?
Who?
Yeah, the grad student.
Oh yeah, they went first, I believe. They're group 1, right? I thought I heard.
No, we were your group number, whatever. I think group 6.
Oh, you were group 6. Okay, my bad. Yeah, go ahead and share.
Okay, so I basically played around, put 2 light bulbs on each side and put fuses in there. And like you said, you mentioned the fuses took the hit, and they were the ones that blew up once I raised the battery power, and the battery also caught fire. So I thought it was pretty cool.
Yeah, awesome. Thank you for sharing. So now we're gonna go ahead and move on to the quiz. So let me go ahead and share my screen for you guys. Just give me one moment. What did you say, Ms. Omar?
Talking about lead and pencils. Can you clarify on that?
Oh, of course. Yeah, so I noticed some of the groups were using the pencil and it was working. So we know that metals are good conductors, and in a pencil there's lead, and we know lead's a metal, so it worked. That's why it worked. However, like lead's not the best conductor, but it still does work. So yeah, does that answer your question?
Thank you.
All right, so let me go ahead and share my screen now. So the pin will be up shortly. Go ahead and get your Kahoot website up on your phone or your computer. All right, is everyone ready?
I think so.
Okay, let's go ahead and get started then. If you still need to enter your PIN, you can just join in. All right, so I'm gonna read each question and go over the answers with you guys. All right, what is the name of the path that electricity goes through to get from the power source to the load? Great job. A lot of you guys got this one right. The correct answer is electrical circuit. So some of you picked wire, and wire is not the right answer because wire is a conductor. So a conductor's job is to allow electricity to flow through, but what we're looking for is the name of the actual path, and that is electrical circuit. So let's go ahead and move on to the next question. How many spaces can there be in an electricity path from the power source to the load in a closed circuit? All right, so our answer is none. We know that for a circuit to work, it must be closed, and for it to be closed, there can't be any gaps at all. If there's a gap, then it's called an open circuit, and it can't conduct electricity. All right, let's move on. True or false? A good example of a conductor is rubber. All right, most of you got this one right. So we know that conductors that are good are usually metals, right? And rubber is not a metal. So rubber is actually an insulator. It's a poor conductor of electricity. All right. Question number 4. In order for electricity to flow through a closed circuit, the circuit must include. All right, most of you got this one right. So a closed circuit must include the power source, a conductor, and the load. So a lot of you picked option 1, and although it looks right, it is missing a key component, and that's the load. You can't have a circuit if you don't have the load. So like in Zayana's example of her circuit, if she didn't have the light bulb, then it wouldn't be a circuit because you have nothing that will be consuming the electricity. And then a few of you picked the option down here, and although this does look sort of right, it is missing another key component, which is the conductor. You have to have a substance or material for the electricity to pass through. All right, so let's move on. Question number 5. What is a flow of charged particles called? Great job, guys. Most of you got this one right. So our answer is electrical current. So we know that the flow of charged particles is called the electrical current, and you guys saw that in your little circuit simulator. You saw all those little electrons moving through, and that's the electrical current. So a couple of you chose electrical circuit, and this is the name of the path of the circuit. It's the name that we use for the path of electricity. But as far as the flow goes, where the electrons are moving, that's the electrical current. All right, so let's go to our next question. What happens when you increase resistance in a circuit? Great job, guys. The right answer is the electrical current slows down. So we know the point of a resistor is to slow down the current. And so when you increase it, you're going to slow it down. And when you decrease it, the current will speed up. So let's go to the next question. Which of the following is a good example of a conductor? Great job. Everyone got this one right. Looks like we're pretty confident with conductors. All right, we have one more question. Which picture shows a closed circuit? Good job. Most of you got this one right. So the first option is the correct answer because there are no gaps here. And some of you picked this one over here. And as you can see, there's a little gap right here. So this is an open circuit, not a closed one. And then one of you picked this one down here. And again, there is a little gap right here. So this one's also an open circuit. All right, so that wraps up our quiz. Let's see who's on the podium.